The scope of this project was to create a mid sized smart hydroponic system that offers automation to the average consumer. This hydroponic system is self contained and irrigates the plants in a controlled fashion. The physical design of this system is a vertical tower. This is to maximize the amount of plants that can be grown vertically and minimize the amount of floor space needed. This allows even those without large yards be able to take advantage of the limited space they may have. An aqueous nutrient solution is pumped from a 20-gallon sump tank located at the base of the tower. Sensors are attached inside the tank to monitor the solution's total dissolved solids and pH, both of which have specific target points for hydroponic plant growth. These values are monitored and controlled through a custom mobile application on a Bluetooth device. Our system features modular options which include indoor LED lighting, a solar panel, and automatic dosing pumps. This helps the user grow plants in places they may not have been able to grow before. The LED lighting will help users grow food indoors in a climate they can control, allowing for year round use of the system. The lights are programmed with a dimmer to gradually turn on and off. Red and blue light frequencies are used to promote plant growth. The system can be powered by the grid or solar power energy. A 100-watt 12-volt monocrystalline solar panel is connected to a lithium ion battery for storage. This is all mounted on a brazed aluminum cart with wheels so that the panel can be positioned in the best location to receive sunlight. The cart weighs approximately 25 pounds. Four nutrient pumps are connected to the sump tank that will automatically dose the system with nutrients and pH solutions according to the sensor readout. This eliminates the need to measure and test the solution manually. Once the correct setting is selected on the mobile application, the dosing pumps introduce the correct amount of nutrients until the sensor measures the correct reading. The mobile application displays the sensor values and also handles other important tasks. If the water level falls below the float switch, an audible alarm can be heard. To distinguish the alarm condition, an alert displayed in the application will specify why the controller is alarming. The application also allows the user to enable the modular add on functions such as automatic lighting and chemical level adjustments. After enabling the function, the user can select the parameters in which the controller commands these modular options. They are the lighting on off times, the pH minimum maximum set points, and minimum TDS set point. Lastly, if the user does not want to enable the modular options in an automatic mode, the application can manually operate the lights or other pumps. We decided to design, layout, and build our own controller board. This controller was designed and laid out in Circuit Studio and built by hand. The controller allowed us to neatly and easily incorporate all sensors, pumps, power, and modular options. The board features a circuit supervisor that monitors the voltage on the solar supply. When there is sufficient voltage, it treats the solar supply as the default power. However, if the voltage from the solar supply is not efficient or non existent, it will switch on the residential supply. We also have an efficient 5-volt buck converter on the board to step down the 12-volt supply to 5 volts for our microcontroller and sensors. This controller is set neatly in a 3D printed case that we also designed. Our team learned many lessons in building the smart hydroponics tower and its modular components. By taking the idea from CAD design conception to completion, this project encompassed many aspects of everyday electrical engineering and the manufacturing engineering process. We learned that dividing responsibilities is important with each member making a different system or modular component. We achieved in creating a commercially manufacturable custom printed circuit board that works with a microcontroller programmed to run the system. With a mobile application that monitors and controls every aspect of the smart tower, we have achieved in building a consumer level hydroponics project that meets all the scope requirements originally laid out. The automatic chemistry modular solar option, as well as the large yield, means we fulfilled the most important system requirements found in our consumer survey. We have successfully harvested plants from different systems and are working on quantifying our hydroponic outcomes.